All right, folks, I think this will be the last video on graphing rational functions. This one's got a kind of an interesting thing going on. Well, let's just do it and figure it out. So the first thing we're going to do is we're going to factor the numerator and the denominator, right? Now here, this numerator, it has a common factor in it, 36, right? So we're going to factor out a 36, and what that leaves behind is x minus 1 over two numbers that multiply to negative 12 but add up to negative 1 are x minus 4 and x plus 3. Okay, now in this case you can see that there is no whole because we don't have any matching factors in the numerator and the denominator. So over here at whole we can say none. There aren't any wholes at all in this function. Okay, which is comforting, right? You know, I mean, if you have an argument, you don't want any holes in your argument. Why would you want holes in your rational function, right? Okay, all right. Don't want to fall in any holes. All right, I'm done. So now we need to find the y-intercept. Remember, for the y-intercept, we just plug 0 in for x. So we're going to put a 0 here. 36 times 0 is 0, minus 36. Put a 0 here. That's 0, minus 0, minus 12. And what we wind up with here is negative 36 over negative 12. Negative 36 divided by negative 12 is positive 3. Therefore, the y-intercept is at 0 and 3. So we're going to go to 0 and 3. 0, 1, 2, 3. And we're going to put a dot there. That's the y-intercept. Okay? We're good there. Now let's find the x-intercept, or intercepts, however many there are. We take the numerator, set it equal to 0. Well, 36 does not equal 0, so that doesn't count. So we're going to ignore the 36 entirely. We are going to take the x minus 1 and set it equal to 0. And we're going to add 1 to both sides, and we get x equals 1. So at x equals 1, there is an x-intercept. So that's 1 and 0. So from here, 1 and 0, x-intercept, we'll put a dot. It's the only x-intercept in this function. Now let's look at the vertical asymptote. To find the vertical asymptote, we're going to set the denominator equal to 0. Well, this is interesting. Our denominator, x minus 4 times x plus 3 equals 0. We have two factors multiplied equal to 0, so we're going to set each one separately equal to 0. And what this means is that we're probably now going to have two vertical asymptotes, which can happen. Here we're going to add 4 to both sides. We get x equals 4. Here we're going to subtract 3 from each side. We get x equals negative 3. So we have a vertical asymptote at 4, x equals 4, and a vertical asymptote at x equals negative 3. Okay. All right, so where is positive 4? So we're going to go over here to positive 4, and we're going to draw a dashed vertical line at positive 4. And then we're going to go to x equals negative 3, 1, 2, 3, and draw a vertical dashed line. So, two vertical asymptotes, which is going to make it for an interesting curve on the function. Okay? So now we want to identify whether there's a horizontal asymptote or a slant asymptote. Now the power of the numerator is smaller than the power of the denominator, so it is not a slant asymptote, but there is a horizontal asymptote at y equals 0. Okay? So we're going to go to y equals 0, the x-axis. Okay, now we've got all of our features graphed, but now this is looking kind of weird, because we have three sections. We have this section on the left side of negative 3. We've got the middle section between negative 3 and 4, and the right side section greater than 4. Okay? Now, we also have this horizontal asymptote, and here's what you need to understand. Horizontal asymptotes only affect the ends, the right side section and the left side section. Now, up to this point, we've only had two sections, a right side section and a left side section. But now we have a right side section, a left side section, and a middle section. that horizontal asymptote has no effect. Well, it's not no effect. Sometimes it can, but it doesn't really have an effect on the middle section. So we got to find out whether this middle section is, whether the asymptote is having an effect at all. Now, I can tell that it's probably not. You know why? Because in the middle section, we have this Xintercept, which means that the graph is crossing over the asymptote. Now, you may have heard that graphs never cross over asymptotes, and that is true for vertical asymptotes, but it is not necessarily true for horizontal asymptotes. It's okay for the graph to cross over the horizontal asymptote as long as it's only happening in the middle. It's just not really going to happen on the right side or on the left side of the graph. Okay? So let's do something. Let's leave the middle alone just for a minute, and let's find out whether we're going to graph in the top or the bottom of the left, and either the top or the bottom of the right. And for that, we are going to need test points. So let's go to the left here. Let's just pick this number as a test point. Let's plug in x equals, what is this, -1, -2, -3. Let's plug in -4. If we plug in -4 in here, we'll get 36 times -4 minus 1 over -4 minus 4, that's -8, okay, times -4 plus 3. Now here, -4 minus 1, that's -5. -5 times 36, that's -150, -180. Over -4 plus 3, that's -1. -4 minus 4, that's -8. So we've got -8 times -1. -8 times -1 is +8. Now look here. We've got a negative divided by a positive. A negative divided by a positive is a negative, right? That means that this graph is in the bottom section. And it's going to pass through this point right here, probably way down here. But just to make it easy, what we're going to do is we're just going to draw a curve that just kind of does this. There we go. It goes along with the horizontal asymptote on the left. It goes along the vertical asymptote on the bottom. And that's basically, all it is like an L-shaped curve in these corner sections here. Now let's find out what's going on over here in the right side. Let's take a test point. 1, 2, 3, 4, 5. Let's plug 5 in. Okay. Well, if I plug 5 in for x, I have 36 times 5 minus 1 over 5 minus 4 times 5 plus 3. Well, 5 minus 1 is 4, and 4 times 36 is 144 over 5 minus 4 is 1, 5 plus 3 is 8, 1 times 8 is 8. We've got a positive divided by a positive. Well, positive divided by a positive is a positive, so we know that it's going to be up here in the top right. Okay? And so what we're going to do is we're just going to come up here and we're just going to draw an arbitrary curve that looks like that. Okay, so we've got our bottom left, we've got our top right, and now we've got to figure out what's going on here in the middle. Okay? What I would do if I were you basically is take a couple more test points. I would test here and see if it's up or down. Actually, it has to be up. Look at this. Hang on a second. Y-intercept, right? X-intercept down here. So we know that it's going to connect somewhere between here, but look, it can't turn down because there would be another X-intercept over here. So it must go up. So it's probably going to do something like this. Okay? And over here, this one can't go up on the right because look, it would have to hook around. Ooh, unless that's a bounce point. Let's go ahead and test over here just in case. Let's test 1, 2, 3. Let's plug a 3 in. If I plug a 3 in, see if I get a negative number or a positive number. I'd have 36 times 3 minus 1 over 3 minus 4 times 3 plus 3. 3 minus 1 is 2. 2 times 36 is 72. 3 minus 4 is -1. 3 plus 3 is 6. 6 times -1 is -6. Sure enough, get a negative number. Therefore, on the right side over here at 3, we know it's a negative number. And so it must be going all the way down here. So what we're going to do is we're going to go ahead and connect these two and then make it do this down here. This one's a little complicated, probably the hardest one we've done yet, but it's doable. As long as you identify these qualities, put in your asymptotes correctly, check some test points, you'll be able to graph it okay. That's all I have for you. That's the graphs of rational functions. Trust me when I say there are lots of very, very difficult rational function graphs out there. And if you really want to get to know rational functions and their graphs, then I recommend picking up a graphing calculator and just having fun with it. Just key in a lot of different rational functions and see what you can change. You can also use the online program Desmos, which is really useful, and you can see instantaneous changes right there. You can even put in variables for the powers and see what happens when one power is higher than another, that kind of stuff. Okay, but I recommend with rational functions, with the graphs of rational functions, you really have to get out there and explore to see what these things can be, because there are lots and lots of shapes, lots and lots of possibilities. Okay, all right, I'll see you guys in class.